Yeah. So now we'll discuss about the concrete pump. So we are. I made the complete presentation of concrete pump in the presentation as well as, and in addition to that, I am giving the complete hydraulic circuit, how the concrete pump works, under what hydraulic, the mechanism involved in it. So this is the hydraulic circuit for an ideal concrete pump. So now here we have these two cylinders. Now you're seeing that these two cylinders here. These two cylinders are the concrete cylinders. Number one cylinder and number two cylinder. These are the concrete cylinders. That is concrete delivery cylinders. You know very well. Now how it works now. So now it has involves here total 6 components involved to function the hydraulic circuit. Number one component is this is the one, the hydraulic motor and the hydraulic pump. From the tank, the oil is sucked by the pump. The motor rotates the hydraulic pump and the pump will suck the hydraulic oil and it goes to the direction control valve. This is 4 position. So 3 position 4 port direction control valve. 3 by 4. This is 3 position 4 port direction control DC valve. So item 1 is the motor with the hydraulic pump. It's going to suck the hydraulic oil from the tank and goes to the direction control valve. And second is here a relief valve with a filter. This is for the return oil. This is meant for the return oil. Now I'll just tell you. Now the oil, in the first stage, the oil is being sucked by a pump. The motor rotates the pump and the oil goes to direction control valve. So this direction control, as I told you, there are 3 positions and 4 port, A to B, B and T are 4 port. In this direction control valve, we have 2 solenoids, solenoid 1 and solenoid 2. If we energize this solenoid 1, now the position will take place, this position here. Understood? And if we energize solenoid 2, this will take this position, 3 position like this. The middle position, and this is a 4 port. Now we will talk about the first position. Now when we energize the solenoid this, we operate the solenoid this, the oil will flow like this. This takes the direction, this position. Understood? This will flow as per this directions. So now the oil will takes and goes here like this, and here the oil goes like this, and oil goes like this, and now here the piston is in the closing stage, and the oil will pushes the piston outside. Now we have 2 check valves here. As the oil goes, now this oil will not go from here because it's a non-return line, non-return check valve. Now here the oil goes here, and see the oil pumps here the piston, and piston will take the retraction and it will come outside. As you come outside, the oil will outside will also take place here. So the oil will goes here also, and the piston comes out, and steadily, and this oil will pump here and goes in, takes entry here, and will push the piston here and will come out, and the oil will come down like this, and it goes to like this direction takes place and comes to the tank. Now here this is a filter. This is the filter. Suppose if the filter is jammed here, the oil will takes flows goes through the relief valve. It will open. So this is the pilot line. It will open this relief valve and comes here. The oil will be drained in back to the tank. If the oil provided, if the filter get choke up. If filter is not choke up, the oil will directly goes through and penetrate through filter and drain to the back to the reservoir and tank. This is the first condition. The second condition, if we operate this solenoid 2, the solenoid 2, if you operate the solenoid 2, it will take the second position, this position. Here comes out here and the pump will directly goes like this. Like see, it will go like this here. This is like this, sorry, and this will be like this. This is up and this is down. So now the oil will goes from A and goes to the cylinder 1, and it will enter here. Now you see, now this cylinder is here. Now when the first position we have seen, this cylinder has taken outside, come outside, and it is going to retract here. And now the position is here. Now position is here. This position is here. So now as the oil pushes here, it will goes out, and suddenly as the oil will come here, and then it will going to retract here. This oil will come here, and again it comes to the down to the filter and drain back to the tank. Or if the filter is jammed, it will take through, the route will be taken through the relief valve. The pilot valve opens it and goes to the tank. This is the operation of relief valve. If supposing if concrete has jammed in the pipeline here, pipeline has been jammed, or many problems comes in the site due to pipeline jam or the shut-off valve jammed. So in that case, entire load will come here on the pump. So we want to save the pump. In order to save the pump, the one line has been given here. This is called the biospring piston. So the biospring, the oil will comes here, and the biospring will this is the variable pump. Now this shut-off plate will come here. Due to this, it will push here. This will bring here. Now the shaft plate will come here. The oil will be there will be no load on the pump, and this load will goes here. So when the oil is try to come here, when this biospring works here, then the pump will, and the shut-off valve will close like this. The minimum load will on the pump, so that the oil will take the other line. So in this other line, we have the mechanism. The mechanism is involves two relief valves. Now here, if you want to, we can control this by a flow restrictor valve, which is called here the orifice. We can increase the flow and by control. This is a uniform control valve, flow restrictor valve. This is a flow restricted variable valve. Understood? So now the oil will go here. If we control here, so the pressure will goes here, and then it goes to the this is a pilot line, and the relief valve opens here and drain back to the tank. If it is not controlled, the oil will take the other line also, the pilot line, and the relief valve open here, and then it goes to the tank. Now this can be here in some other pumps. We can to control the load. In order to control the load, so that the pump should be saved. In the pump has jammed, so the entire load comes to the pump. When the concrete has jammed, entire load try to come on the pump. So we can, instead of this area, we can install one accumulator. This is the accumulator, which can be used to control. This is the accumulator. The function of accumulator is the oil will not go here. This is optional line, you can say. Either this or this. So the oil will goes here and goes to the accumulator. Accumulator has a bladder. It will take entire oil inside till the load has not been cleared. Means the concrete has been not cleared. It will take entire oil has been accumulated here. This oil has been accumulated in the accumulator to maximum extent. As soon as the concrete has been cleared, so the oil will again come back to the line through the accumulator and start the operation. So this is the function of a normal concrete pump hydraulic circuit. So this reason I believe you might have understood the concept. If anything is doubt, if you have anything doubt, let me know. And if you have not subscribed my channel, please do subscribe my channel and press the bell icon as well. Okay.